Let's look at another example, given a formula finding the domain of the function. This function is f of x equals 1 divided by the quantity x minus 11 times the square root of x plus 11. And there are a couple of things that we should notice right away. One is we still have the issue that the function has a square root. So the presence of the square root over x plus 11 implies that we need to have x plus 11 be greater than or equal to 0. Secondly, the product x minus 11 times the square root of x plus 11 is in the denominator and therefore needs to be different from 0. If I solve the first constraint, x plus 11 greater than or equal to 0, this by itself would give me x greater than or equal to negative 11. But I need to also look at the second constraint. If x minus 11 times the square root of x plus 11 is to be different from 0, then I need x minus 11 and the square root of x plus 11 to also be each different from 0. Therefore, x cannot be 11, and x plus 11 itself can't be 0, so x also can't be negative 11. When we put all of this together, sometimes it's easier, at least it is to me, to draw things out visually on a number line. The first inequality was x greater than or equal to negative 11, but you've contrasted that you can't have negative 11 with the second constraint. You also can't have 11. So I can have everything beginning at negative 11 and to the right of it except positive 11. This means that my domain in interval notation would be parenthesis negative 11, comma 11, parenthesis, and then union, parenthesis 11, comma infinity, parenthesis. In other words, the interval is negative 11 to 11, not including the endpoints, and then 11 to infinity. And look at our choices. Typically, you don't look at your choices until you've tried to work out the problem, or you might confuse yourself. So notice that there's really only one choice that is exactly what we have determined we need.